It's probably easier to explain the sorts of questions that you could ask with this activity by using a screencaster and actually looking at the animation. So here we've got the Doctor Who file set up. Now you can see here I've got a center there, a center of enlargement, which on my video is turned white, so it looks like one of the stars. And up here we've got the scale factor of enlargement that's being used. So if we were to take that scale factor up to say 1, we'll see that there is actually only one polygon there, one octagon in view, because all the others are enlarged by a scale factor of 1, which means they're the same size and in the same position. So as we increase that scale factor by small amounts, we can see them begin to separate. At this point, you can be asking questions about the gap between them, and does the gap between them stay the same? What's the relationship between the gaps? And in the description of the task, it does say that it's a repeated operation. So why are there so many? Well, it's because they've been repeated. There is only one variable, which means that the gap between them does stay the same. But obviously every time you increase the gap by one, you increase all the gaps by 1, and so on. Okay. Now the other thing we can do now is think about the variables. Well, one variable is the center of enlargement. One, the scale factor we've just been messing with. The other one, the center of enlargement. So if I pick up the center of enlargement, the position of the subsequent polygons, not the original one, changes, and so that's where you get this nice kind of disappearing down a tunnel effect that we've got here. And if it's inside the shape now, so all the enlargements go around the outside, and now it's the other side of the shape, and obviously the position of all the enlargements is completely dependent on that center of enlargement, each enlargement of course being dependent on the previous enlargement, and so on. So that's how we get that cumulative effect. And now of course if we go back to the scale factor, we can see that kind of disappearing effect that we've got going on there. Okay, so the real question now then for me, the real surprise that I like, is what happens here when this scale factor becomes negative. So we've gone all the way back down to 1, and I think it's easier to demonstrate this one by moving the center of enlargement outside the shape. Okay, so we now decrease this scale factor. It's 1. It's getting smaller, getting closer to 0, and so they're all between the original shape and the point now. They're a fractional scale factor, and I think that's easy enough to understand. What happens when the last of those disappear and we've got 0? They've all been reduced to 0. Now, hold on, 1 comes out the other side, and then back the other side, and there's this kind of ping pong or alternating effect, and we've got 2 different tunnels now coming out, which is a really nice effect, a really nice demonstration of that alternating pattern that happens when you use a negative scale factor. And so it's really nice to linger on those points when you're looking at that one. It's a toss-up. What's the best way to ask this question? To show the video and say, well, why is that happening? Or to say before you do it, what is going to happen when the scale factor becomes negative? And people think about going the other side, and of course it looks like it's 3-dimensional, but isn't necessarily. And it's harder to see that they're alternating at that point, but when it's closer to 0, it's easier to see that they are sort of coming out one after the other, with the negative multiplier pinging them backwards and forwards between positive and negative positions. So that's just an idea of some of the questions, some of the things that can come up, some of the discussions you can have with classes when you're looking at this particular